In this lesson, we're going to look at finding real zeros of cubic functions. So we're going to focus just on functions with degree 3. And so the objective here is to find all real zeros of a cubic function. Now, this is a continuation of a previous lesson. So in the previous lesson, we found rational zeros of a cubic function. And so if you recall, when we when we found the rational zeros, you notice that all of our zeros were rational numbers. So these were rational numbers. In every case in this lesson, all of our zeros turned out to be rational numbers. Okay? So in this case, though, remember a real zero can be rational or irrational. So a real zero is rational or irrational. And so in this particular lesson, the one that we're about to look at, some of our zeros will be irrational. Okay? All right, so let's look at an example. Okay, so example one, it says find all real zeros of this function. So we have 5x cubed plus 29x squared plus 19x minus 5. Now remember when in the previous lesson we used these steps to find the rational zeros of polynomial. But these steps still hold true regardless of whether our zeros are rational or irrational. So for right now, I'm going to use the word real. So we're going to find the real zeros of a polynomial. And in fact, guys, we can use this to find real or non-real zeros. So remember, the non-real zeros are the ones with the imaginary number. So remember the ones with I. Okay? All right, so remember the first thing you're going to do is you're going to list your possible zeros. So using the Rational Zeros Theorem, which remember is sometimes called the rational root theorem. Okay? So let's go ahead and list the possible rational zeros. So possible rational zeros. All right. So remember, we're going to list the factors of the constant term in the numerator. So they'll be the factors of -5. And the denominator would be the factors of the leading coefficient. So my largest degree term is x cubed. So the coefficient is 5. So the factors of 5. And so I get plus or minus 1, plus or minus 5. And the denominator I have plus or minus 1, plus or minus 5. Okay? So then remember, though, we wrote this in a better way. So we said, well, the possible factors in lowest terms, possible factors, and when I say possible factors, I mean the possible rational possible zeros, possible zeros, possible rational zeros. Let me go ahead and write that in. Possible rational zeros will equal, so 1 divided by 1 is 1, so we get plus or minus 1. Plus or minus 1 divided by 5, plus or minus 1/5. And then 5 divided by 1 is 5, plus or minus 5. And then 5 divided by 5 is 1. And we already have it listed. So those are the possible rational zeros. Now remember, the possible rational zero theorem, or the rational root theorem, only says that if you have any rational zeros, it will be one of these. Okay, it doesn't say that you will have any. It just says if you do have any, it will be one of those. Now remember, what most students do is they try the integers first. So most students will try 1 first, then they'll try 5, then they'll try -1, -5, and they'll deal with the fraction, the 1/5 last. So let's go ahead and use that approach. So let's try 1. Let's see if 1 works. So remember, the next step is you use synthetic division to find out which of those possible rational zeros will give you a 0. Okay? All right, so we're going to try 1. And remember, when using synthetic division, any missing terms, you must use 0, and it must be in descending order. So we have 5, 29, 19, -5. So I didn't have any missing terms. Again, you may want to use your calculator to help you with this. So we bring down the 5. 1 times 5 is 5. 29 plus 5 is 34. 1 times 34 is 34. And then we add them up. 19 plus 34 will give us 53. And then 1 times 53 is 53. And obviously, you know you're not going to get a 0 here. So that'll be what? That's what? 48? Okay. So 1 is not a 0. Not a 0. Or a root. So let's try 5. So let's see if 5 works. Do the same thing. So 5, 29, 19, negative 5. So we bring on to 5. 5 times 5 is 25. We add them up. 29 plus 25 gives us 54. All right, and so 5 times 54 gives us 270. Now you know from here you can see that's not going to work, right? 270 plus 9, because there's no way you can get a 0 here, because you need this to be a positive 5, right, to get a 0, and you can see it's not going to work. So you could, in essence, just stop here if you want to, but I'm just going to show you you're not going to get a 5 here. So 270 plus 19 will give us 289, and you see 5 times 89 is not positive 5, right? And then 5 times 89, 289 rather, gives us 1,445, which gives us 1,440. So 5 is not a 0. So remember, there's no easy way to do this. We talked about that before. No easy way to do this. You keep trying something until you find one that works. And remember, they may not all work. All of these zeros here in a polynomial, they could all be, in this case it won't be, but in a polynomial, you could have all, especially if this is an even root, x to the 4th power, you could have all non-real zeros. And we're going to talk about that. And sometimes it could be all irrational zeros rather than rational zeros. Okay, so let's try -1. All right, see what happens there. 5, 29, 19, -5. So we bring on the 5. 1 times -5 is -5. When we add them up, we get, what's that, 24? -1 times 24 is a -24. When I add these up, let's see, I get, what's that, a -5. -1 times -5 is a +5. And so I get 0. So I found it. So I found one of them. So -1 is a 0. All right, now remember what we did. So remember this is cubic, right? We only dealing with cubic. So that means that when you rewrite this function in factored form, we have this. We have, I'm going to go ahead and use another sheet of paper. So we have this now. So we have f of x. I'm going to go ahead and rewrite the function. So f of x, which was 5x cubed plus 29x squared plus 19x minus 5. So now remember, if -1 is a 0, then that means one of your factors is x plus 1, right? Because remember, if I set that equal to 0, I get -1. So it's x plus 1. All right, now the quotient, this is your quotient right here. So that's your remainder. And that's your quotient. Remember how we did this? So since this is cubic, then this is linear right here, then x times x squared must be x cubed. So that means that this must be 5x squared and then 24x, right? And so now this becomes 5x squared plus 24x minus 5. All right, and then what we did, so remember what we did next. So repeat steps 1 and 2 for the quotient. Stop when you reach a quotient that's quadratic or factors easily. So we reach a quotient that's quadratic. If you don't want to try and factor this, you can use the quadratic formula, but let's try and factor this. So we get x plus 1 times, and let's see, that'll be 5x, x, and remember I want a positive 24, and the only factors of 5 are 5 and 1. So let's put the 5 here, the 1 there. The last sign's negative, that means these signs are different. And the outer and the inner, the larger of those must be positive. So it looks like this is the positive, this is the negative, and let's just verify it works. 5x times x is 5x squared. A negative 1 times 5 is a negative 5. The outer is 25x, the inner is a negative 1x, and I get 24x. All right? And so then what we did next was we set each of those factors equal to 0. So I get x plus 1 equals 0, 5x minus 1 equals 0, x plus 5 equals 0. And so I get x to be negative 1, x to be 1/5, and x to be negative 5. And so those are your zeros. And it turns out that these are all rational zeros. So we have three distinct, and remember what I mean by distinct, different, three different zeros, three distinct rational zeros. All right? Now they're real, though those are real numbers, right? Rational numbers are real numbers. It just so happens in this case that those are rational zeros. All right, those are our zeros. Okay, so that was that first example. Let's look at another example. All right, so in example 2, we have this cubic function. And let's go ahead and do our steps. So remember, I'm using these steps here. So if you need to go back to those steps, just go back to those steps. All right, so the first thing we got to do is list the possible rational zeros. Possible rational zeros. Now remember, it may not have any rational zeros. May not have any. They could be non-real or irrational. But let's see if we have any possible rational zeros. So possible rational zeros. All right, so remember, you're going to list the factors of the constant coefficient, which is negative 12. That's your numerator. And then the denominator are the factors of the leading coefficient, x cubed. The leading coefficient is 2. And so we get in the numerator the factors of negative 12 are plus minus 1, plus minus 2, because 2 goes into 12, 3 goes into 12, 4 goes into 12, 6 goes into 12, and 12 goes into 12. All right, so those are your possible factors of negative 12. For 2, the only possibilities are plus minus 1, plus minus 2. All right, so let's go ahead and simplify this. So the possible rational zeros are, okay, so here we go. 1 divided by 1 is 1, so plus or minus 1, plus or minus 1/2. All right, so that takes care of the 1. Now let's do the 2. 2 divided by each of those. 2 divided by 1 is 2, plus or minus 2. 2 divided by 2 is 1, I already have it. Let's go to the 3. 3 divided by 1 is 3, so plus or minus 3. 3 divided by 2 is 3/2, so plus or minus 3/2. 4 divided by 1 is 4, so plus or minus 4. 4 divided by 2 is 2, I already have it listed. 6 divided by 1 is 3, I already have it listed. I'm sorry, 6 divided by 1, I don't have it listed, so plus or minus 6. 6 divided by 2 is 3, I already have it listed. 12 divided by 1, I don't have it, so it's plus or minus 12. 12 divided by 2 is 6, I already have it listed. So remember, the rational zero theorem says that if you have any rational zeros, rational now, not irrational, rational, it will be one of these. Okay, it doesn't tell you you'll have any, it just tells you that if you do have any, it'll be one of these. So remember, most students will try the integers first. So let's go ahead and try 1 first. So let's try 1. So we have 1. Remember you're going to use synthetic division to see if 1's a 0. All right, so I don't have any missing terms. It's already in descending order. So I have 2, negative 11, 20, negative 12, right? All right, so bring on the 2. 2 times 2 is 2. Negative 11 plus 2 is a negative 9. 1 times negative 9 is negative 9. 20 and a negative 9 is 11. Obviously, you see you're not going to get a 12 here, right? Because 1 times 11 is 11, so you get negative 1. So that's your remainder. So that means that 1 is not a 0 or a root. Okay, so let's try 2. Let's see if 2 works. And by the way, you could have tried -1 next if you wanted to. So some students will try +1, -1, then +2, -2, then +3, -3, and so on. Remember, there's no easy way. It's just trial and error. That's all this is. 2, -11, 20, -12. All right. So we bring down the 2. 2 times 2 is 4. -11 plus 4 is a -7. Um, and 2 times -7 is a -14. 20 and -14 is 6. 6 times 2 is 12. And there you go. We get 0. So that's your remainder. So that means 2 is a 0. Now remember, what that means is that if 2 is a 0, that means x minus 2 is a factor, right? So now what we're going to do is we're going to factor, since this is cubic, then remember your quotient now is quadratic. Okay, quadratic. So we have f of x equal, all I'm doing is just rewriting the original function. Okay, all right, so I'm rewriting the original function. All right, and so I get f of x is going to equal, so if 2 is a 0, then that means x minus 2 is a factor. And then your quotient, so remember your quotient, if you need to, write it out. So these are your coefficients of your quotient, so that's 2x squared, x, and your constant. So I get 2x squared minus 7x plus 6. All right, and it looks like this is factorable, so let's go ahead and factor this. So, and you could use a quadratic formula, does not matter. Okay, so I get, let's see, 2x, x, and I need the possible factors of 6, 6 and 1, 3 and 2. So let's try 3 and 2. So let's put the 3 here, the 2 here. The last sign's positive, so these signs are the same, so they're both negative. And before you go on, verify. 2x times x is 2x. -3 times -2 is a positive 6. The outer's a -6. I'm sorry, the outer's a -4. The inner's a -3x, and so I get -7x. All right, and so I factor this, and notice those are all going to be rational zeros. So remember, you set each one equal to 0 using a 0 factor property. So you get x minus 2 equals 0, 2x minus 3 equals 0, x minus 2 equals 0. All right, and so notice these two are the same, right? So keep that in mind. So we get x equal 2, x equal 3 halves, and x equal 2. So notice, remember in the previous example, in example 1, I said this. I said we have 3 distinct rational zeros, distinct meaning they're all different. Notice though, I have 3 zeros, right? But they're not all different. These are the same, so x equal 2 are the same. Okay, so I'm going to write it this way. I have, so these are your zeros, so you're going to say your rational zeros are 2 and 3 halves. Keep in mind though that when we say these are rational, I'm just going to use the word real. So the real zeros are, because you're trying to find the real zeros. Real zeros are 2 and 3 halves, which are rational. But here's what we say though. We say the zeros are 2 with, no, and we talked about multiplicity before, 2 with multiplicity 2, because 2 occurred as a 0 twice. All right, and so your factors, see you have 2x minus 2. So if you think about it, you can write this as x minus 2 squared times 2x minus 3. Remember that? So 2 occurs as a 0 twice. So we call it multiplicity. So zeros are 2 with multiplicity 2 and 3 halves. Okay? All right. So we still, now remember, we talked about a theorem in previous lessons that says, see that degree here? So the degree, so you're going to have 3, since the degree is 3, you're going to have 3 zeros, including multiplicity. So notice I had 3 zeros, right? It just turned out that you only have two distinct zeros. 2 occurs as multiplicity 2, and 3 has occurred only once. All right, so you have two distinct real zeros. 2 distinct real zeros. All right, You still have 3 zeros, but 2 are distinct. 2 are different. 2 and 3 halves. So you see you have 2. It just so happens that the 0, 2 has multiplicity 2 because it occurred twice. All right, sometimes we call this a double root. So sometimes we call um, multiplicity 2 a double root. Okay. All right, so that was example 2. All right, now keep in mind in the first example and second example, our real zeros were all rational, right? In the first two examples, our real zeros are all rational. So let's now look at one that's irrational, where we have irrational roots. So this is example 3. So example 3, let's suppose our function is this. All right, so let's suppose we had x cubed minus 4x squared plus 8. All right, so let's suppose we had that. Okay, so remember step 1, you list your possible rational zeros. So the possible rational zeros possible rational zeros. So we have the factors of the constant term, which is 8. So the factors of 8. And then the factors of the leading coefficient, which is 1. So we get plus or minus 2. I'm sorry, let's do 1 first. Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And the denominator, the only factors of 1 are plus or minus 1. And so when we rewrite this in a better way, so the possible rational zeros are 1 divided by 1 is 1. So we get plus or minus 1. In fact, see, 2 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 8 divided by 1 is 8. So we get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. All right, so let's find something that works. So let's try 1 first. All right, now remember, we do have a missing term, right? The x term's missing. So we got to, remember, we're going to put a 0 here when using synthetic division. So we have 1, negative 4, 0, and 8. All right, bring down the 1. 1 times 1 is 1. Add, negative 4 and 1 is a negative 3. Multiply, we get negative 3. Add, we get negative 3. And obviously, you know you're not going to get a negative 8 here, right? Because 1 times negative 3 is a negative 3. So we get 5 instead. So there's your remainder. So that means 1 is not a 0 since the remainder is not 0. Okay, so let's try 2. Let's see if 2 works. So we have 1, negative 4, 0, 8. Okay, bring down the 1. 2 times 1 is 2. Negative 4 plus 2 is a negative 2. Multiply. 2 times negative 2 is a negative 4. Add, we get negative 4. Multiply, we get negative 8. And now we get remainder 0. So that means 2 is a 0, or a root. So that means that since 2 is a 0, I can factor this. So we're going to factor f of x, which equals x cubed minus 4x squared plus 8. So since 2 is a 0, that means one of your factors is x minus 2. And the other factor is going to be this quadratic. So remember, the quotient here is your other factor. All right, so remember, since this is cubic, this is cubic, so that means x times x squared must be x cubed. So this needs to be x squared, and this will be x. All right, so we have x squared minus 2x minus 4. All right, now this is not factorable. All right, so if we could factor this, I just want you to remember this. If you could factor this, then you would end up with if you could factor this over the rational numbers, then each of those would be rational. Your zeros would be rational, but yet you cannot factor this. So let's use the quadratic formula. So what I'm going to do is this. So remember what we did in the previous two examples was we set each of those factors equal to 0. See how I factor this quadratic? And then we found the zeros, right? Those are the zeros. We're going to do the same thing here. So I get x minus 2 equals 0, and then x squared minus 2x minus 4 equals 0. This is linear, so we know that one of the zeros is already 2. We knew that. We knew that already, that 2 is a 0. But let's find the zeros of this quadratic equation now. So I'm going to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So remember, a here is 1, b is negative 2, and c is negative 4. So make sure you list your a, b, and c's correctly. And so we can substitute these values into our formula. So this says the opposite of b. So b is negative 2. The opposite of negative 2 is a positive 2. Plus or minus the square root of b. Be careful, make sure you say negative 2 squared in parentheses. Minus 4 times a is 1, times c, which is negative 4, all divided by 2 times a, and a is 1. So this becomes 2 plus or minus the square root of negative 2 times itself is 4. So remember, b squared must always be positive or 0. B squared is never negative. So be careful if you're going to use your calculator with this. So that's why we put that in parentheses, because that means a negative 2 times itself, positive 4. A negative 4 times 1 times a negative 4 is a positive 16, all divided by 2 times 1, which is 2. So this becomes 2 plus or minus the square root of 20. 16 plus 4 is 20, divided by 2. And so notice that these are irrational numbers. So I have a rational number and an irrational number, because the square root of 20 is not a perfect square. So the square root of 20 is irrational. So this is an irrational root, an irrational zero. Okay. Now I'm going to go ahead just to remind you how to simplify the square root of 20. So remember, the square root of 20 is going to be the square root of 4 times the square root of 5, right? And the square root of 4 is 2 square root of 5. So remember, to simplify the square root of 20, you find a perfect square and always use the largest that goes into 20. And so I'm going to rewrite 2 square root of 5 here. So this becomes 2 plus or minus 2 square root of 5 divided by 2. And notice these 2's are divisible by this 2. So 2 divided by 2 is 1. 2 divided by 2 is 1. So you get 1 plus or minus the square root of 5. All right, so I'm just going to say this. If you leave your answer like this at this point in this course, if you leave it like this, I'm fine with that. So you can say your zeros are 2, and then 2 plus or minus the square root of 20 over 2. But this is what you would see as an answer. So if this is multiple choice, that's what you would see. You would not see this. You would see this instead. So just want to remind you how to simplify this. So the zeros are 2, 1 plus the square root of 5, 1 minus the square root of 5. So you see you have three different zeros. Your degree is 3. So you have 3 zeros. It just turns out that these are 3 distinct zeros. So we have 3 distinct zeros. Also keep in mind, 1 is rational, and what kind of numbers are these? Irrational. So 1 is rational. 2 are irrational. Okay? Now I want to remind you about something, just to remind you. Remember that 1 plus the square root of 5 and 1 minus the square root of 5, remember those are conjugates? Okay, that's going to be important in a little while. So these are conjugates of each other. 1 plus the square root of 5 and 1 minus the square root of 5 are conjugates. Okay, so that was number 3. Okay, so we have in number 3, we had irrational roots. So if you have any irrational roots, you're going to have to use quadratic formula when you get to this quadratic equation. All right, so you see this quadratic factor? You're going to have to use a quadratic formula because this cannot be factored. All right, so in the previous example, this quadratic, and you could have used a quadratic formula, by the way, but notice that this was factorable, and you ended up with rational zeros. This is not factorable, so you ended up with irrational zeros. Okay? All right, let's look at one more example, and I think we should be done with this. So this is example 4. Example 4. Okay, so in example 4, we have this cubic. So you notice that as we did these problems in this lesson and the previous lesson, we were dealing with cubic. So notice in every situation when we set each of those equal to 0, we had 3 zeros. So and it turns out that the degree here, whatever the degree is, in this case it's 3, you're going to have 3 zeros. They may all be different. You may have some being the same, which in this case involves the idea of multiplicity. Some could be rational, some could be irrational. That's what we saw, right? Okay. Now in the next lesson, that's where we're going to start talking about non-real zeros. So some could be imaginary, could contain that number I, the imaginary unit. Okay. So let's list the possible rational zeros. So possible rational zeros. Okay, so the factors of your constant term, which is 12, that's your numerator. Your denominators are the factors of the leading term, the leading coefficient, which is 5, factors of 5. And so we get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. The denominator, plus or minus 1, plus or minus 5, right? Okay, so let's rewrite this in a better way. So the possible rational zeros are 1 divided by 1, 1 divided by 5, and so on. So we get 1 divided by 1 is 1. So we get plus or minus 1, plus or minus 1/5. 2 divided by 1 is 2, plus or minus 2. 2 divided by 5, plus or minus 2/5. 3 divided by 1 is 3, plus or minus 3. 3/5. 4 divided by 1 is 4. 4/5. We have quite a few, don't we? 6 divided by 1 is 6, and then 6/5. 12 divided by 1 is 12, and then 12/5. We have quite a bit of possible rational zeros, don't we? Okay, so remember, there's no easy way of determining which of these is a rational zero if this does have any. Okay, we don't have an easy way of doing that. So again, most students will do 1, 2, 3, 4, 6, 12, and then they'll do the negatives in that process and so on. All right. So again, no easy way, guys, of doing this. It's just trial and error. Now, on your test, I'm just going to let you know in this class, in your test, you're not going to have that many, especially all these integers. So you have quite a few here. So I'm not going to do that to you. But for homework, you have plenty of time. You do have plenty of time to kind of go through the process. So let's try one first. So synthetic division, remember we're using these steps right here. Okay. So there are no missing terms. So we're going to say 5, negative 20, negative 3, 12. All right, bring down the 5. 1 times 5 is 5. Negative 20 plus 5 is negative 15. 1 times negative 15 is a negative 15. And obviously you see you're not going to get a negative 12. You can see that now, so you can stop and go on to the next one. But if you could continue, you have negative 18, and that's a negative 18, which gives us negative 6. So 1 is not a 0. All right, let's try 2. Let's see if 2 works. So we go to 2. 5, negative 20, negative 3, 12. So we bring on the 5. 2 times 5 is 10. Add, you get negative 10, right? Negative 20 plus 10 is a negative 10. Multiply, you get negative 20. And then so that's negative 23. And obviously you know you're not going to get negative 12 because that's what? Negative 20, negative 46? And so we get a negative 32, I'm sorry, 34. So that means 2 is not a 0. All right, we continue on. Let's say you want to try 3, 5, negative 20, negative 3, 12. So it's just trial and error, trial and error. And you don't have access to a graphing calculator in this course, so you could put this in a graphing calculator and kind of see where the zeros are. Remember, the zeros are your x-intercepts. But in this course you don't, so you have to do this process. So we have 5. 3 times 5 is 15. Negative 20 plus 15 is negative 5. 3 times negative 5 is negative 15. Obviously, you see that's not going to give you, you're not going to end up with negative 12. Negative 18, and you see when you multiply 18, negative 18 times 3, you get a negative 54. So you know you're not going to get 0 there, right? Okay, so that means 3 is not a 0. So in fact, you get what? Negative 42? So that's not a 0. That's not 0. All right, so you're probably getting tired of this. Like, you're thinking, well, I'm going to have to try about 10 of them. Well, let's try 4, 5, negative 20, negative 3, 12. Again, I'm not going to put something like this on a test with all these possible rationals. Okay, so 4 times 5 is 20. Oh, that's nice. That's 0 already, right? That's 0. Negative 3. Oh, there we go. 4 times negative 3 is negative 12. I get a remainder of 0. So I found it. I found a 0. So 4 is a 0. Okay, now, remember the next step. The next step is to write this as a quotient now. All right, so I'm going to need another sheet of paper. So we have this. Remember, let's go ahead and factor. I'm going to go ahead and factor this now so I can find the zeros. We have at most 3 real zeros. Some could be, we could technically end up with non-real zeros. But remember, in this lesson, they're all going to be real. And they're not going to be non-real. Okay, so f of x, remember, is this. It's 5x cubed minus 20x squared minus 3x plus 12. So let's go ahead and factor this. So since 4 is a 0, that means x minus 4 is a factor. And then your quotient, these are the coefficients right here. So remember, this is your remainder. And so since this is cubic, since your function is cubic, then your quotient has to be quadratic. Okay? And so notice what we have. We have 5x squared minus 3. That's what we have. Okay, 5x squared minus 3, because 0 times x is 0. Okay, now I want to let's go ahead and since this is not factorable over the integers, let's go ahead and set each one equal to 0 to find the zeros. So we have x minus 4 equals 0, 5x squared minus 3 equals 0, right? Okay. And so if I said this is linear, this is quadratic, so this x here is 4, which we already knew, right? We knew 4 was a 0 from here. Okay, now here's what some students will do. You could use the square root property here. Most students won't. What most students will do is they'll use the quadratic formula. Now I'll come back and show you the square root property with this. Since the x term's missing, you could use the square root property since the x term's missing. But let's use the quadratic formula first. So I have a is 5, b is 0. Remember the 0 is the coefficient of x. There's no x here, so you got to say 0. And c is negative 3. And so remember quadratic formula, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so we get the opposite of b. So the opposite of 0 is still 0, right? Plus or minus the square root of b, which is 0, squared, minus 4 times a is 5, times c, which is negative 3, all divided by 2 times a, which is 5, right? That's 5. And so I get 0, plus or minus the square root of 0 squared, 0 times 0 is 0. A negative 4 times 5 is a negative 20, and a negative 20 times a negative 3 is positive 60. All divided by, what's that, 10? So I get the square root of 60, I'm sorry, plus or minus the square root of 60 over 10. So that's what I have so far, right? That's what I have. Okay? Now, remember, 0 plus or minus the square root of 60 is plus or minus square root of 60. Don't forget the plus or minus, though. Some students forget about that, plus or minus. Okay? Now, technically, you can. I'm okay with you leaving your answer like this. So you have 1, and then a positive square. Let me just say this. You have, so the zeros, so the real zeros are 4 plus, well, the square root of 60 over 10, and the negative square root of 60 over 10, right? So you see you have 3 different zeros. One is, this one's rational, and these are irrational. These are irrational. Okay? So you have, so these are my real zeros. So my real zeros are these 3. I have a rational and 2 irrational. And notice just like the previous one, and let me go ahead and quickly find it. Just like the previous one, remember these are irrational, right? They occurred as conjugates. 1 plus the square root of 5, 1 minus the square root of 5. Kind of makes sense because of that, in the quadratic form, you have that plus or minus. Same thing here. These are conjugates. Positive square root of 60 divided by 10, negative square root of 60 divided by 10. Makes sense because of the quadratic formula, plus or minus. Okay, so the irrational zeros, they occurred in pairs. Saw that? Conjugates, conjugate pairs. The irrational zeros occurred in pairs. 1 plus the square root of 5, 1 minus the square root of 5. All right? Okay, now, what I want to do, again, you could leave your answer like this, but what I want to do is remind you how to simplify square root of 60, because if in my math lab, it could be multiple choice. And in my math lab, they could tell you, make sure this is simplified. Okay, so I need you to be aware of that. If it says in simplified form, then you gotta simplify the square root of 60. All right, so let's do that. The square root of 60. Square root of 60. We gotta find a perfect square that goes into 60, and try and find the largest perfect square that goes into 60. So let's try 4. 60 divided by 4. 60 divided by 4 is 15. So 4 is a perfect square that goes into 60. So I'm going to rewrite this as square root of 4, square root of 15, right? Because 4 times 15 is 60. And the square root of 4 is 2, so you get 2 square root of 15. So what that means is that, see the square root of 60 right here? Let me go ahead and do that here. So we have the square root of 60 plus or minus the square root of 60 divided by, see this plus or minus square root of 60? So plus or minus 60 divided by 10 is plus or minus 2 square root of 15, because square root of 60 is 2 square root of 15, divided by 10, and then I can reduce 2 divided into 10. So that's 1, that's 5, so I get plus or minus the square root of 15 divided by 5. And that is, in my math lab, if they say, write your answer in simplified form, then this is what you want. Okay, so you can also write it as this. Also write as, you could say 4 square root of 15 divided by 5, negative square root of 15 divided by 5. Now, see, you can also write it like this. I just want you to remind you about this. You can also say 4 and then plus or minus square root of 15 divided by 5. All right? Just like over here, you could have said right here, where we had 1 plus the square root of 5, 1 minus the square root of 5, you could have also said this. 2, you could have said 1 plus or minus the square root of 5, which came from here. Okay? All right. So the point I want you to be aware of is this. The irrational zeros occurred in pairs. Those were conjugates. Square root of 60 divided by 10, negative square root of 60 divided by 10, which reduces this. Plus or minus square root of 15 divided by 5. Okay? So that brings us to this. So let's look at this now before we end this lesson. Okay, so recall from previous lessons that complex numbers a plus bi and a minus bi are called conjugates. So we haven't talked about imaginary units in with these yet, but you did talk about those in previous courses and previous lessons in this course. The same thing with irrational numbers. So a plus the square root of b, a minus the square root of b are called conjugates. All right, so that brings us to this. If a complex number or an irrational number is a real zero of a polynomial, and remember, we call it a zero or a root of a polynomial function or equation with rational coefficients. So notice that in, let me quickly find our example. So notice that these coefficients, 1, -4, and 8, are rational numbers. So with rational coefficients, so is its conjugate. So what that means is this. Notice that if 1 plus the square root of 5 is a 0, then 1 minus the square root of 5 is a 0. If the one we just did, if square root of 60 divided by 10 is a 0, so is negative square root of 60 divided by 10. So that's what that says. So if you have a polynomial and the coefficients are rational, if you have any irrational zeros, its conjugate will also be a 0. If you have any non-real zeros, its conjugate will also be a 0. Okay? All right, now, okay, so this, I think we have enough, we did enough problems and enough discussion to complete this lesson. So this was a lesson on finding the real zeros of cubic functions. So in this lesson, keep in mind in this lesson, we had at most, we had 3 zeros. Some had multiplicity of 2. Some of our functions had 3 different zeros, like you saw. Okay, um, but in this case, though, our zeros are either rational, irrational, or a combination. In the next lesson, and we're going to do cubic again. That's where we're going to see where we're going to have non-real zeros. So that imaginary number. Okay. All right. So that's the end of this lesson.